Parent functions. Now, parent functions are sometimes called common or basic functions, and the basic idea here is that these are functions without any movement, meaning we're not moving vertically, horizontally, there's no shifts, and there's no compressions, no stretches or reflections. They are just basic functions. And we're going to look at quite a few examples of these. The first is the square function, which is f of x, or that could be y, equals x squared. You'll notice this is a parabola, so the basic function of x squared opens up. And if we think about the points on this basic function, if I plug in -2 for x, well, -2 squared is a +4. So you can see in this table, we have -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. You can match them up with points on the graph. When you move forward into transformations where you are moving functions, you can use the basic or the parent function to help with that. So that is the x squared, the square function. Next, we move into the cube function, which is f of x equals x cubed. You notice the graph of this is different, obviously, than a square function. Here we have more of a droop, right? Starts low, negative, it's increasing as it gets to 0. It seems to flatten out a bit and then continues to increase. If we look at a table of this, you will notice if we plug in a negative value for x, it gives us a negative value for the output. So a -2 yields a -8, and that is why we start in quadrant 3 in the negative area and we increase as we go. Our next function is the square root function. So f of x equals the square root of x. As you know, you cannot take the square root of a negative number. So our smallest value in our table is 0. So the square root of 0 is 0, and then we move to the positives from here. You'll also notice in my x column, I'm only using perfect squares because the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. With these types of functions, when you create a table, you want to use tables, numbers in that table that are easy to calculate, which is why I chose perfect squares for the square root function. Next, we have the cube root function. If you think about back to when we talked about the cube function, this was more of a vertical looking graph. Well, the cube root, which is the cube root of x, is more of a horizontal looking graph. But it's very similar. Increases as we get to 0, seems to level out a little bit vertically now, and then increases on. So again, when we look at our table, if we plug in a negative value, we can have a negative cubed root because we know -2 times -2 times -2 does yield -8. So the cubed root of -8 is -2. So it's the inverse or the opposite of the cube function. And you'll notice a similarity if you compare those two tables. The next parent function is the absolute value function. The absolute value function, remember, absolute value is the distance from 0. So when I plug in a -2, well, a -2 is 2 units from 0, so the absolute value of -2 is 2. You will notice this yields a v-type function. I always think about an absolute value. The graph of that is a v in some way, shape, or form. So the parent function graph of the absolute value function has a vertex at 0, 0, right? That's the kind of the point of the v, and then we increase at a +1 slope to the right, a -1 slope as we move to the left. So similar in looks to the square function, but here, because it is the absolute value, it is straight lines where a parabola is curved. And the last one we're going to look at is the reciprocal function, which is f of x equals 1 over x. You'll notice these graphs live in quadrant 1 and quadrant 3. So if I plug in a negative value for x, I get a negative value for y, which is why it lives in quadrant 3. If I plug a positive value in for x, I get a positive value for y, which is why it also lives in quadrant 1. You'll notice 0 is missing from the table because if I plug in 0 for x, that's the denominator. We can't divide by 0. That does not work. So you'll notice that our graph never touches 0. It never touches y equals 0, and we can't put 0 in for x, so it never touches y equals 0 as well. And those are kind of the basics of the parent functions for the most common functions.